These are two solar distillation units. They are very low-tech but very effective ways of taking undesirable water. It's dirty, it's too salty, it's got bacteria, it's got minerals you don't want. You can take that undesirable water, place it inside the still, and through the process of being heated by the sun, evaporating, and then condensing on the surface of the glass, or in this case, plexiglass and then glass there, and drips down into a trough and flows into the jar. It's kind of like what happens with rainwater. The sun heats the ocean, heats a lake, heats a river, the water evaporates up, it condenses into clouds, and when the clouds get to a certain size, it rains. And that's the same thing here. You can see it where the water's evaporating up, the little water droplets are kind of like the clouds, and when you get a water droplet of a certain size, it will drip down and start the whole process going. We decided to do some research on these because of the needs of some communities in southern New Mexico, in Mexico, internationally, where they have water perhaps, but it's impure for whatever reason. Again, dirty, bacteria, salty, and we wanted to make these such that they could be constructed in just about any place. Both of these are made out of simple materials. That one's made out of an old toolbox. This is made out of polycarbonate, which is available in every continent on the planet. And this one's got a polycarbonate front, which is unbreakable. That has a glass front, which is a little more efficient, but you could break it. The idea is they could take this, and if they're in a situation where they have water, whether it's at their home or if it's in a disaster situation, like in Haiti or in New Orleans or in Pakistan, where people were dying of thirst, even though there was water everywhere. Of course, they couldn't drink the water because it was undesirable. But with a small unit like this, somebody in a disaster situation could provide enough drinking water to serve their needs. We've figured that for a family of 4, each person consumes about 1 gallon a day in drinking and cooking water, that for a family of 4, 2 square meters would be about enough. 20 square feet in the American units, and so something 6 by 3, 7 by 3, you could provide enough water for a family of 4. Of course, in the summer with greater solar energy, you get a little more water, but again, with that 2 square meters, you could make about 4 gallons a day, which would be enough for the family of 4. Here in New Mexico, down in Columbus, they have groundwater, not too deep, but the groundwater has lots of uranium and lots of fluoride in it. A family could put this, take the water that comes out of the tap, you could shower with it and wash with it, but for drinking, you'd take 4 gallons, put it into the solar still, and create pure water that you could easily drink. It comes out about 99.9% pure. So you can basically take as junky a water as you can get and make incredibly pure water out the other end.